let's say today that we're southwest of Great Bend, Kansas, coming up from Dodge City on Victor 502, and we're planning an instrument approach to Great Bend. Now, we are flying a GPS-equipped airplane, but the database isn't current, and a GPS approach wouldn't be safe or legal. And not only that, Center has told us that the ILS at Great Bend is out of service. So guess what that leaves? You got it, an NDB approach. So let's get ready to fly an NDB approach. Now, it's very helpful to know how to do an NDB approach well, because there are hundreds of airports that only have an NDB approach, and having the ability to fly the NDB approach opens up all those airports to you. Now, the rub is that the NDB approach is probably the one type of approach that gives the pilot the least help and the highest workload. But that's no problem for you, because you've had the best training in the world, and you'll be prepared to do an NDB approach well. So let's self-brief the approach. On the way up from Dodge City, I listened to the Great Bend AWOS on frequency 119.9 when I was about 25 miles out. Now, the weather at the airport isn't bad. It's awful. When we get there, it'll be right on the ragged edge of our minimums. Now, we have the right chart here. It's Great Bend Municipal Airport. The wind is from the north, so we'll use the NDB or GPS runway 35 approach. The communications frequencies are, of course, listed right here on top. And as you know, these symbols with reverse type next to the frequencies tell you about the pilot control lighting, and they're associated with the frequency you'd use for the lights. Now, you can see that there is something a little unusual about this setup, because the common traffic advisory frequency of 122.8 turns on the high intensity runway lights on runway 1735. But the other frequency, 122.5, turns on all the other lights. Well, let's check out the navigation frequencies. Now, the approach is based on the locator outer marker, BABSI, and the frequency is 419, and the identifier is GB. Now, there is a feeder route from Hayes, which is on frequency 110.4, and the identifier is HYS. And by the way, this channel number tells me that Hayes is a VORTAC, and it has DME. Now, if I were to fly on that feeder route, the altitude would be 3,500 feet, the course would be 141 degrees, and the distance would be 40.9 miles. Now, there is another feeder route in from Hutchinson, which is on a frequency of 116.8. The identifier is HUT, and once again, that channel number tells me that this is a VORTAC. Now, since I'm coming in from the southwest, I probably won't use either one of these feeder routes. In fact, I'll probably be just cleared direct to BABSI. Now, since it doesn't say no PT, I can't make a straight-in approach unless ATC vectors me to final. So I'll plan on flying direct to BABSI, turning around, and then flying south on the 171 course. And then, when I'm established southbound, do the procedure turn and fly back to the NDB on the 351 course. Now, checking out the minimum safe altitudes, I find that the MSA is 3,500 feet between the 260 and the 360 inbound bearings. And what's this? It's blank for the rest of the circle. That looks to me like a printer's error. So let me flip over the page to the ILS plate, which has a minimum safe altitude circle. And by the way, it's based on the same fix. So we should see there, yep, it's right, there should be something printed in there, and it's 3,900 feet. What's that do for your confidence? Well, checking the profile view, I see my altitude will be 3,500 feet until I cross BABSI inbound. And then my MDA for a straight-in approach will be 2,300 feet. That's 417 feet above ground level. Now at 90 knots, the time to the missed approach point from Babsy will be 3 minutes and 24 seconds. Now I'll be descending from 3,500 to 2,300 feet, and that'll be 1,200 feet. And since this is a non-precision approach, I'll use my 800 feet a minute rate of descent. Now, it'll only take me about a minute and a half to get down, so I should have plenty of time to get stabilized at the MDA and be looking for those approach lights. Now, the missed approach instructions are for a climbing left turn to 3,500 and back to Babsy and then hold. Now, notice there is a holding pattern here shown for the hold. That's pretty easy to remember. I'll be climbing, making a left reverse course back to Babsy and going up to 3,500 feet. Now, as I approach the holding pattern, I'll need to do a right turn to stay in the protected area, so I'll be using a teardrop entry. Now, let's check out the airport diagram. See, I can expect high-intensity runway edge lights for runway 35, and by the way, that reverse type L in the black circle confirms that those lights are pilot-controlled. Now, from the communications section, I remember that I'll use the Common Traffic Advisory frequency of 122.8 to do this. Now, that A5 tells me that runway 35 has a medium-intensity approach light system with runway alignment indicator lights. Now, the dot on top of this circle tells me that the system has sequence flashers. The V inside that circle tells me that runway 35 has a VASI. And again, these symbols are black with reverse print, which tells me that they're pilot controlled. Now, when we checked out the frequency section, we learned that we'll use frequency 122.5 to control those lights. Now, this is such an unusual arrangement that I checked out the airport facility directory during my pre-flight planning to make sure that that's the way it is, and that is the way it is. It doesn't say why, but that's the way it is. You know, that could keep a guy pretty doggone busy. Well, now I'll scan the chart to remind myself of any special notes around here. This note says inoperative table does not apply to Cat C. Well, we are not flying a Category C airplane, so that will not be a problem for us. Now, let's review the most important things to remember from the self-briefing. First of all, they are, how low can I go? And the answer is the minimum descent altitude is 2,300 feet. How far can I go? Well, I can go until 3 minutes and 24 seconds from Babsy. And finally, which way do I go on a missed approach? Well, in this case, I'll make a climbing left turn back to Babsy and go back to 3,500. And even with this good approach self-briefing, I'll still make sure I keep this chart handy. There's no way I can remember all this stuff.
Cessna 9 Echo Sierra, clear direct to Babsy. Cross Babsy at 4,000. Clear for the NDB 35 approach to Great Bend Municipal. Report Babsy inbound.
Cessna 9 Echo Sierra, direct Babsy, cross Babsy at 4,000, cleared for the NDB 35 approach to Great Bend Municipal, call Babsy, inbound. Now, all I have to do now is fly direct to Babsy and descend to 4,000. Now, this is a great time to make sure that I'm all set up for the approach. First of all, I'll tune and identify Babsy. And since there's no off flag on the ADF, I'll just leave the volume up so I can barely hear it. Now, it looks like a heading of 060 to Babsy, so I'll take up that heading and reset my ADF card. Next, since there's also a marker beacon at Babsy, I'll make sure that my marker beacon audio is turned on, and I'll test it and set the sensitivity. Now, I'm already working with center on my #1 comm, so I'll keep that for my talking radio and set up 122.8 here on the standby side. Now, I used the #2 comm to copy the AWAS weather earlier, so I'll just leave that there in case I get a chance to update our weather, and then I'll put 122.5 on the standby side to be ready to activate the lights. Now, if I have to go somewhere else, it looks like Hutchinson and Hayes, along with Dodge City, are my most logical alternatives. Well, I was already using Dodge City for my navigation earlier with Nav 1, and with Hutchinson in standby, and I'll just leave that the way it was. Now I'll plug in 1110.4 in the number 2 nav, and I should have all the bases covered. Now I've got everything all set up except for the GPS. And you know what? If this were a real flight in real weather instead of a training flight, I'd be using that GPS too for position awareness, even if it isn't legal to use it for IFR as my primary source of navigation. I'd be using it as a backup anyway. And I'll make sure here that my timer is all set up and ready to go. And as usual, I'll use the audio panel here as a checklist to make sure I've thought of everything. Now to do the before landing checklist. Pilot and passenger seat backs, most upright position. Seats and belts secured and locked. Fuel selector valves on both. Mixture's rich. The landing and taxi lights are on. And the autopilot's off. And with that, we're all set up and ready for the approach.